So yesterday we started our discussion of eccentric loading. In eccentric loading, guys, everyone just have a look. I will give you just a brief revision of that basic example one what we discussed in last lecture, guys. Everyone. Now everyone. So in that basic example, we have seen what is meant by eccentric loading, guys. What we have seen? What is meant by eccentric loading? So here F, instead of F acting perpendicular to the beam or along the center line, everyone just have a look here. So what we discussed, guys, this F, instead of acting on the center line or perpendicular, where it is acting, guys, little bit away from center line. Because of that, we have two effects. So now one more thing. So this F, distance of F from the center line, what we will say that distance is what, guys, everyone? Eccentricity. What we will say, guys, everyone, this distance? Eccentricity. And eccentricity stands for what? Distance between line of action of force and center line, everyone. So now due to this F, two effects is going to create. What are the two effects, guys? The first effect is what? Due to eccentric load, following two things going to take place. First is what? Compression of the column. It means decrease in length of the column, and due to this direct stress is going to develop in the cross section, and that direct stress is what? Sigma D is equal to F by A, and nature is what? In this case, compressive. This direct stress is same everywhere on the cross section. Means if this is a cross section of the column, if we consider 3 points here, guys, just imagine that one point is here, another point is here, and another point is here. So all anywhere on the cross section, guys, doesn't necessarily A, B, C point only. Anywhere, any point on the cross section, direct stress is what? Same. Means you can consider here, 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 anywhere on the cross section, direct stress is what? Same. And nature of the direct stress is what here? Everyone tell me? Compressive. Why compressive? The force that we are applying is of what? Compressive nature. The force here that we are applying is of what, guys, everyone? Compressive nature. So remember this thing. Now the next thing is what? The second effect of F is what? Bending of the column. Now how the beam is going to bend, how the column is going to bend here, guys? Like this. Because of that, what is going to happen? So because of that bending, because of that bending, what is going to happen? Bending stress is going to develop in the column. Now here, in this case, as column is a vertical, so how to show the neutral axis, guys, everyone? Neutral axis will also, this is what a cross section, guys. Remember, see, on the view of column, this line, this black color line will become what? Center line. On the view of cross section, the same extended line, we will show it as what, guys? Neutral axis. These two things are different. Why we are calling this as a neutral axis? Because about this axis, which thing is zero, guys, everyone? Bending stress is zero.
Bending stress is zero.
So that's why about this neutral axis is what, guys? What is zero? Bending stress is zero. That's why we are saying it as what? Neutral axis, everyone. And now important, as this column is going to bend like this because of this given force here, what is going to happen? At this point A, which type of bending stress is going to develop, guys? Tensile bending stress, maximum tensile bending stress. And at this point C, on this view, C is look like here.
Compressive.
So maximum compressive bending stress. Maximum tensile bending stress we denote by F max T. Maximum compressive bending stress we denote by what, guys, everyone? F max C. So now here in this case, F max T and F max. Means F max T and F max C is what? Same. And why same? Because it is a symmetrical about neutral axis. Guys, I am explaining what is the meaning of symmetrical about neutral axis. Left hand side, for this scenario, left hand side and right hand side. They are mirror image of each other. So now, because of this bending, what is going to happen? What is going to happen? Due to bending stress is going to develop on the cross section of the column. Bending stress is not same everywhere on the cross section of the column. Maximum bending stress is at the maximum distance from a neutral axis. And that maximum bending stress will be what, guys, everyone? M by I into Y max. That is what we have seen. Now we have to see. So therefore, net stress at each point. Means here we have seen, means you can see any point. Net stress at each point is a combination of what, guys, everyone? Direct stress and what, guys, everyone? Bending stress. So net stress at point A will be what, guys? Suppose just we want to say net stress at point A. Now what we discussed, guys, what I told you, everyone? Every point has a two stresses. Which two stresses, guys? Direct stress. Every point has a what, guys, everyone? Two stresses. One is what? Direct stress and bending. Now tell me at point A, what is the nature of direct stress, guys? At point A, what is the nature of direct stress? Direct stress nature, guys. Compressive. Direct stress nature is what? Compressive. And what is the nature of bending stress, guys? Tensile. So at point A, direct stress is in compressive nature, bending stress is in tensile nature. So overall combination is what? Difference of that two. So net stress at point A will be what, guys, everyone? What will be net stress at point A? If bending stress is higher, then net stress at point A is what? F max minus sigma d, and nature will be what? If sigma d is what? Higher, then if sigma d is higher, then what will going to happen, guys? If sigma d is higher, then sigma d in minus F max, and nature of sigma d will be applicable.
Compressive.
Everyone getting my point? Then net stress at point B. If you observe, guys, point B, on point B is on what? Neutral axis. Neutral axis bending stress is 0. So only stress will remain then, guys, what? Direct stress.
Direct stress.
Direct. So net stress at point B will be what, guys, everyone? Sigma d, and nature is what, guys, everyone? Compressive. That is what we have seen. Now then net stress at point C will be what, guys, everyone? Tell me. So see, if you observe at point C, what is the nature of direct stress at point C, guys? Compressive, guys. I told you, compressive, direct stress is the same everywhere and same nature here everywhere. So at point C, direct stress compressive. At point C, bending stress is what, guys? Compressive. Direct stress compressive, bending stress compressive. What we will get, guys? We will add what, guys? Both. So everyone getting the point. So then net stress at point C will be what, guys? Sigma d plus what?
F.
And nature will be what, guys? Overall will be
Compressive.
what? Compressive. Everyone? Michael sir? Okay, what is your doubt? Tell me.
I asked yesterday, what will be the effect of this distance E, sir? We are not taking.
See, why? See, 1 minute, guys, 1 minute. I miss very important point here. What is the effect of? Yeah. Okay. See, guys, everyone, I miss very important point. Here, while dealing with the calculation of F max, what we need, guys, everyone? We need the M. We need the M. From where we will get the M? Where? By? See.
Moment.
So that moment will be what in this case? Here M will be what, guys, everyone? Force
into the distance E.
Distance E. From where we will get it, guys? Beside this drawing, beside this relation, I missed that important point, guys, everyone. Yesterday, very good. So here, where, guys, beside this relation, use a red pen, guys. Try to use a relation. This M, who is creating a M, guys, here? Who is creating a moment? Who is creating a moment? Because of that eccentricity. Force is not creating a moment. Oh, force is creating a moment. But if just imagine that, tell me, if this force is act at this point, guys, just at this, tell me, is there any moment here? So who is creating moment, guys, in this case? This force F is creating a force F is what? This distance distance E is creating a. So guys, everyone, try to see the scenario here, everyone. So before going further, what you have to do, guys, everyone, beside this relation of F max, guys, beside the relation of F max, you have that relation of F max, everyone. Beside that relation of F max, what you have to write down? M will be equal to what, guys, everyone? Try to write down in red pen or different color pen. F into small e.
Okay, sir.
Everyone added this effect of M, and what will be the unit of M, guys, everyone? Tell me.
So Newton meter.
Unit of M will be what, guys, everyone? Newton meter. Now everyone, give the next heading. Basic example 2. Everyone, give the next heading. Basic example 2, guys, everyone. Now in basic example 2, stories is some little bit different, guys. Not different, same story. See guys, same story. Everyone observe the scenario here guys. Everyone, I'm going to copy the same drawing. Just same drawing I'm going to copy here. I have that option. Same drawing I'm going to copy. But few things are going to change here. We will see that things also. 1 minute. But you don't have that option of copy paste. I have option, everyone.
Can we draw now or
No, nothing. You don't have to write anything. Don't do. First of all, let me complete the things and then I will give you a proper time to write down the things, guys.
Okay, sir.
So now, everyone, in basic example 2, this is the scenario of basic example 1. Everyone, this is the scenario of what, guys? Everyone, basic example 1. Now, in basic example 2, here F is what? Compressive in nature. Instead of compressive in nature, what we are going to do? F we are going to show in what, guys? Everyone, tell me.
Tensile.
This F is of what, everyone? Of what, guys? Everyone, tell me. Tensile in nature. Guys, observe. Here F is of what? Tensile in nature. Because of this F, how the column is going to bend, guys? Everyone, how the column is going to bend? Everyone.
Left hand side.
So column is going to bend like this. Everyone, observe. So this way column is going to bend. Everyone observe. This is just one rough drawing. The column is going to bend what, guys? Like this. Everyone observe the scenario here. So this is center line. Column is going to bend like this. Observe. Now due to this one, so at every point, so this here creates what, guys? Everyone, two effects. Direct stress. Now I'm not going to write down that much in detailed way, guys. Here the only few things I'm going to write down here. Now due to this here, two effects is going to create. One is what? Direct stress. And direct stress will be what, guys? What will be the value of direct stress? Tell me, everyone. Sigma D is equal to what? Same. F by A.
F over A.
F by A. But in this case, what will be the nature of direct stress, guys? Everyone tell me. Tensile.
Tensile.
Direct stress will be what? What will be the nature? Tensile in nature. So here we will get a what? A direct stress. Everyone. So here we will get a what, guys? Everyone? Direct stress. Observe the scenario here. Now the next thing is what, guys? Everyone, observe the important point here. So here we have what? A center line. Now everyone, now because of this column is going to bend like this. As this column is going to bend like this, now here, as always at neutral axis, which type of stress we will get? Bending stress is what? 0 at neutral axis. That's why we are saying neutral axis. But at point C, in this current scenario, what is the nature, guys? Maximum tensile or maximum compressive bending stress? In this
Maximum
case,
Exam tensile.
maximum tensile bending stress. Observe here. What we will get, guys, here? Maximum tensile bending stress. And how we denote that one? F max T. Tensile. F max T. Now at point A, tell me which type of bending stress, guys? Maximum compressive or maximum tensile? Maximum compressive. So at point A, what we will have, guys? Everyone, maximum compressive. Guys, observe. If you have any doubt, please feel free to ask me, guys. See, maximum compressive bending stress. And how we are going to denote?
F max C.
F max C. But guys, we discuss whenever we have a symmetrical cross section about neutral axis, F max T and F max C will be same. And how we denote that one? By only what? Simply we denote by what, guys? Everyone? F max. Everyone getting my point? Now here, what we discussed, guys, earlier, every point will be what, guys? Every point will be combination of, every point on the combination is combination of two stresses. One is what? Direct stress. Another one is what? Bending stress. Every point is what, guys? Combination of two stresses. One is what? Direct stress. Another one is what? Bending stress. Now, so here F max will be, what, guys? Everyone, maximum bending stress. Same. M by I into Y max.
Y max.
Everyone. So maximum bending stress will be at outer fiber, means maximum distance from neutral axis. So I'm not going to write down that much theory here. And where M will be equal to what, guys? Everyone tell me. F into E. Guys, this is the one scenario I am explaining you. It is not necessary that always only these two scenarios. We will see in numerical. There will be more advanced scenario, guys. If you observe this numerical, just have a look at this numerical. See, if you observe this numerical, here see, forces is what, guys? Everyone tell me. Inclined. Here vertical. So here one is inclined force, another one is what? Vertical force. Story will be complicated like that. Then if you observe this scenario here instead of column, what we have, guys? Everyone, beam is here. Instead of column, what we have, guys? Everyone, beam is here. Story is what? Again complicated, guys. Story is not that much simple. Everyone, try to see the scenario here. So this is what one simple scenario I am explaining you. Don't consider it is only theory. Try to understand the concepts only. Now then, so net stress at point A, guys. Everyone, we will see net stress at each point. Means not each point, only that three points is important for us. One point is at the left end, another point is at neutral axis, and the next point is what, guys? Right end. So these 3 points are important for us. Other also not that much important, guys. So net stress at what, guys? Everyone, at point A. Now everyone, what will be the net stress at point A? Now tell me, at point A, what is the nature of direct stress, guys? Everyone,
Compressive.
Tensile.
guys, what is the nature of direct stress here? Everyone,
Tensile.
don't see the previous exam. What is the nature of direct stress, guys? Everyone,
Tensile.
direct stress nature is what? Tensile. Bending stress nature is what, guys? Everyone, compressive. Difference. See, the nature is not the same. Direct stress nature tensile, bending stress nature compressive. So everyone, whenever we have here two scenario will come. If direct stress is greater than bending stress, just imagine that, then net stress at point A will be what? Sigma D minus F max. And which will be the nature here, guys? Everyone tell me, tensile or compressive?
Tensile.
Why tensile? Nature of the direct stress, guys. Because whatever the higher value. The second case, guys. If F max greater than what, guys? Everyone, sigma D. If F max greater than sigma D, then net stress at point A will be what? F max minus D. And nature will be what, guys? Everyone?
Compressive.
Nature will be what, guys? Everyone? Compressive in nature. Everyone getting my point? Try to understand the scenario here. We are discussing very, very important points here. And it is applicable everywhere, guys. If you want to add two stresses, then their nature must be same. If their natures are different, then we can't add. We have to subtract higher minus lower, and nature will be what, guys? Everyone? Higher nature. Higher value nature, guys. This is the same thing will be applicable everywhere. Then net stress at point B will be what, guys? Everyone tell me. Net stress at point B. Can anyone tell me here in this scenario? 1 minute, guys. We have not drawn drawing. So I'm going. So sigma B. So at net stress at point B will be what, guys? Everyone? Net stress.
Sigma D.
Only sigma D. Sigma D. And overall effect is what, guys? Everyone? Overall effect is what, guys? Everyone? Tensile in nature. Any doubt in this discussion? So net stress at what? Point B. Then net stress at what, guys? Everyone? Point C. So sigma C will be what, guys? Everyone? Tell me. Net stress at point C. Direct stress nature? Tensile. Bending stress nature? Tensile. Added. So both is the same. So tensile. What will be the scenario, guys? We can add. So sigma D plus what, guys? F max, and overall effect will be what, guys? Everyone? Tensile. Now try to see the scenario here. Everyone getting my point? Try to understand this thing here carefully. So before going further, so everyone give the heading basic example 2. In yesterday we have seen basic example 1. There we have studied the things in more detailed way. But here just a brief introduction how the story will become. Everyone do the heading basic example 2. And now start.
Excuse me, sir.
Yes, sir.
Sir, just like the point A, where the bending stress F max is greater than your direct stress direct stress delta F.
Sigma D.
Yeah, sigma D. So in that case, sir, if your F max is greater than your sigma D, then the deformation will be the same as it is shown over there.
See. Don't worry about the stresses, sir. Don't worry. I will tell you. See guys, everyone. More story is yet to come. Guys, more story is yet to come. See, here I am telling you, it doesn't necessary that beam is going to bend like this only. This is not necessary that beam is going to bend like this only. Whatever the overall effect, this effect I am showing you, only bending effect I am showing you. But actually, the combination of what? Direct means the combination of what will be what, guys, everyone, what I told you? Means we have to see the combination of two things. One is what? Compression of the column, and what? Bending of the column. If there is extension, instead of compression, we will say extension. We have to see that effect. So it is not necessary that I am showing the shape that currently I am showing is only shape of the bending effect. I am showing this shape. But if you want to see the overall effect, then we have to see combination of direct stress and bending stress, guys. This is the effect that I am showing you. It is not necessary that beam is going to bend, means shape of the beam after that loading will be like this. It is not necessary. Beam will remain like that, or beam will go in different scenario, or beam will not do anything, guys. Beam will remain like that only. This is the shape that I am showing you, only the effect of the bending, guys. Nothing else. If there is only bending, this is the only. But actually, it is not only bending scenario. It is a direct stress scenario also. Expansion or compression. In this case, extension is there. So, it may be extension scenario or maybe compression scenario. You have to see that one. So, don't worry about that one. You will understand more things in our upcoming discussion, guys, while dealing with numerical. So, now guys, before going further, everyone give the heading basic example 2 and start drawing this figure, guys, properly, everyone. Completed, guys, everyone? No?
Yes, sir, complete. Completed.
Write down this discussion, guys, everyone. Sigma D F max. After that, guys, everyone, write down net stress at point A. Completed, guys, everyone, to this point. Then write down net stress at point B, everyone, and net stress at what, guys? Point C. Write down this one.